All right, this is the second video in the Learning Target 6 word problem videos. These problems will all be of the distance problem style. And the problem that I'm doing is on page 597. And of course, the notes in the book are going to be exactly what I do in this problem. Unlike the first problem of the first video, the mixture problems, I performed a different method. But in this problem and in the work rates, it will be the same. But it sometimes helps to hear it instead of just looking at the work in the book. So, distance problems. It works based on the fundamental concept that distance is rate times time. Example, if you take off driving in your car 50 miles an hour for 2 hours, you'll end up 100 miles away. Rate times time equals distance. So when I set up a problem that involves distance, rate, time, I set up a table that involves that concept. Rate times time equals distance. So pause the video and read the question, and then once you've read the question, we'll go through it quickly. So hopefully you pause the video. Sandra is rowing a canoe on a lake, which is a little confusing. Unlike most lakes, this one has a current. So being from Kentucky, western Kentucky, we can sympathize with that because Kentucky Lake has a river running through it. So it's more like a river than a lake for most people. But we have a lake that has a river in it. So anyways, moving past that, the first thing I pick up on is it's a 10-mile round trip. So when you're moving with the current and you're moving against the current, a round trip would be 5 miles ways. So I've got a with the current, rate, time, and distance, so 5 miles with the current. And I've got an against the current, rate, time, and distance, but it will also be 5 miles. So that takes care of the 10 miles. All right, now we'll slow down with this next piece of information that says it takes 3 hours to do so. Because going with the current and going against the current, it's not going to necessarily be an hour-and-a-half trip both ways. Instead, it's actually going to be faster with the current and slower against the current. So what do? Do we take an hour with the current and 2 hours against? Or is it 1.1 hour with the current and 1.9 against? We don't know exactly how that breaks up. We just know that it's going to be faster with the current. So all we can do is say, I'm going to change this 5 back to red. All we can say is that with the current will be some time, against the current will be some time, but we know that they add up to make 3 total hours. So I call this the glue statement. This is actually what time 1 plus time 2, this is what's going to bring all this information together and allow us to solve for the missing rate of the current. The time 1 plus the time 2 must add up to 3 hours. So again, that statement eventually is what's going to create an equation for us to solve. But moving on, the rate. It says that Sandra's rowing 6 miles per hour in still water. So let's pretend for a moment that the river has a current of 2 miles an hour. When she's rowing 6 and the current's helping her 2 miles per hour each stroke, she's actually going 6 plus 2. She's going 8 miles per hour. Then she goes to her destination and turns around, and now she's going against the current. So that 2 mile an hour current is slowing her down. So instead of traveling the 6 miles that she's rowing, she's actually traveling 4 miles per hour. All right, so that's helping us figure out the rate, and sometimes you've got to put yourself in the situation of the problem to see what's going on. Let's now pretend that the current of the river was 10 miles per hour. If that's true, going with the current, she'd be traveling 6 plus 10, 16 miles per hour. But when she turns around and goes back against the current, that 10 mile an hour current and her paddling 6 miles per hour isn't going to work because she'd actually be going backwards. If she's rowing 6 but the current's fighting her at 10 miles per hour, she'd be going backwards. So what we can conclude from those examples is that she's traveling faster than the current. So our rate with the current is 6 plus the current, and her rate against it will be 6 minus the current. Again, that's important because if we had switched it to current minus 6, if we had the letters and the numbers in a different order, it just wouldn't have made sense because when she's going against the current, she'd have been rowing backwards. So we've got our information filled out in the table. We agree that distance is rate times time. So now we're going to use a different version of the same formula. Divide both sides of the formula by r. And if you divide both sides of the formula by r, you get t, time, equals distance over rate. So what we can now do is take this blue time and represent it as distance over rate. Distance 5 over rate 6 plus c. So that blue time can be represented by the fraction 5 over 6 plus c. The red time, the time traveling against the current, can similarly be represented as the distance 5 over the rate 6 minus c. In that glue statement, those two times can be added, and they should equal 3 hours. So now I'm going to draw a line because we have passed the point of learning target 6. Learning target 6 was above. Everything about the table, extracting the information, setting up the equation. Everything below is learning target 5. Solving a problem, solving a rational equation that has different denominators. So I'm going to go through the next part rather quickly. So if you need help with the next part, ask me in class, or you can go back and look at the Learning Target 5 video. But we're going to multiply by the LCD. And the LCD is 6 plus c times 6 minus c. So multiply both sides by 6 plus c times 6 minus c. When you multiply the 5 times the 6 plus c and times the 6 minus c, you'll get a numerator of that. When you multiply the denominator, 1, times the denominator 6 plus c, you'll get the original denominator 6 plus c. So we've multiplied the LCD to the first fraction. Now we'll multiply the LCD to the second fraction. So that original 5 will get multiplied by 6 plus c times 6 minus c. And the denominators will get multiplied. And the denominator will be 1 times 6 minus c. So it will stay 6 minus c. Adding those fractions, and it will equal 3 times 6 plus c times 6 minus c. All right, I'm going to actually go ahead and multiply 6 plus c times 6 minus c. I'm going to go ahead and FOIL that out because I see that I'm going to be solving a quadratic, and I'd like to go ahead and start to distribute and combine like terms. So when you FOIL 6 plus c times 6 minus c, when you distribute that, you'll get 6 times 6, 36. The outer is negative 6c, the inner is 6c, they cancel, and then c times negative c will be negative c squared. Hopefully if things worked, our fractions are going to cancel and go away. So 6 plus c is canceling, 6 minus c is canceling. Sorry about that. The fractions are going to cancel, and we're going to be left with the 5 times the 6 minus c plus the 5 times the 6 plus c. And it will equal the 3 times 36 minus 6c squared. So I'm going to go ahead and distribute that 3. So 108 minus 3c squared. Distribute, combine like terms, and continue to solve the quadratic. So 30 minus 5c. 30 minus 5c. 5 times 6, 30. 5 times c, positive 5c, equals 108 minus 3c squared. We got like terms of negative 5c and 5c. They're going to cancel. Got a 30 and a 30, it's going to make 60. And then we got everything that is like terms combined. So we're solving a quadratic. And normally I would say you want your quadratic to equal 0. And that is true for almost every situation. So when you're solving with the calculator or factoring. But this is a special situation where c squared is the only c. And when that's the case, you can get that c squared by itself, subtract the 108, divide by negative 3. And then you can take the square root. So that's the method I'm going to finish solving this quadratic because it rarely can be used, but it can be used in this situation. So subtract 108, divide by negative 3, and we get 16 equals c squared. And you take the square root of both sides, and you get c equals plus or minus 4. You got two options, positive 4 for the current or negative 4 for the current. Well, negative doesn't make sense because the river's not going to flow backwards. So the final answer is 4 miles per hour. Now, the frustrating thing about these distance problems is, unfortunately, not all of them will work the way we just did. That glue statement, if you will, the thing that puts it together, which in this problem was the first time plus the second time equals 3, is not always the statement that will put them together. So when you get to the homework, feel free to ask questions when you come back because there will be a problem or two that works a little bit different than the one we just did.